All right, good morning everybody. I think we are now recording. Medyo bago yung interface ni Teams, pero yeah, I think the recording is on. Good morning everybody, and welcome to week 2 of Math 191. I hope you had the time to download a copy of the second module. I think I uploaded it last Sunday or early kahapon, but you can download it now. And for this week, we'll just start building up the mathematics for inverse problems. Specifically, we'll be looking at operators and there are certain and some properties of operators that are very crucial in solving and analyzing inverse problems. So in particular, ito yung objective natin for this week and for this module. First, we will discuss, or you should, after the module, you should be able to discuss why a thorough understanding of a governing principle in a phenomenon is vital in solving inverse problems. Kasi i-justify ko muna bakit natin kailangan pag-aralan yung governing principle sa pag-solve ng inverse problem. We might be thinking that it is only crucial when we are when we are solving forward problems, and the analysis will be different kung inverse problem yung sinusolve natin. But it turns out the a deep and thorough understanding of the governing principle is very important, not only for the forward problem, but for the inverse problem as well. And then we will look at some ideal properties of a mathematical problem. And in particular, our goal is to learn what a well-posed and consequently an ill-posed problem is. Kasi gusto kong ma-enumerate nyo at ma-explain kung ano yung mga ideal properties of a mathematical problem. In general, we will see that we want mathematical problems, be it forward or inverse, be well-posed. Kasi tingnan natin ano nga ba yung requirements parang isang problem ay maging well-posed, right? Tapos kamalas-malasan, makikita natin na lahat pala ng mga inverse problems or almost all of them are ill-posed, all right? Or hindi naman lahat, pero yung mga interesting inverse problems ay ill-posed. Kasi kung hindi ill-posed yung inverse problem, ibig sabihin there's nothing much to study, So parang magiging inversion lang yung gagawin mo. Pero or pagkuha ng inverse ng forward operator, but that's not exciting for us. So gusto nating pahirapan yung sarili natin. So we look at more mathematically challenging and interesting inverse problems, which turns out to be ill-posed. At doon iikot yung ating semestre sa pag-tackle ng iba't ibang ill-posed inverse problems and how to solve them, right? We're looking at several methodologies on how to address the ill-postedness of inverse problems. And then lastly, I want you to be able to give some examples of inverse problems, all right? At sa homework for this week, ay guided naman. So may bibigay ako sa inyong ill-posed problem, kailangan yung ma-prove or ma-illustrate na siya talaga ay ill-posed. Speaking of which, at the end of the module, you'll find homework number 2, which will be due on Monday, right before midnight, September 19th. By the way, I hope you had the time to take a look at graded homework 1.1 and 1.2. Some generic comments. Yung iba, siguro 30% of answers to homework 1.2. Remember, homework 1.2 is for you to devise your own inverse problem. Siguro around 30 to 40% is very much similar to the examples I gave in class. So I was really hoping that you will give me something new, all right? Yung something na hindi ko naisip that is really applicable to your own field of study or field of interest. But there are really some interesting ones. I just forgot to take note of the names of those who submitted very interesting at alam kong mga inverse problems na allied sa kanilang specialization. There was somebody who wrote about cryptography, all right? Sino nga ba nagsagot nito? May isang nagsagot ng cryptography. Tama ba spelling ko? So dun sa cryptography, all right? Remember, the idea is you want to communicate in secret, right? So you have a sender, okay? Tapos meron kang message. Tapos yung process na pagdaraanan niya is encryption. And this can be thought of as a forward problem. So meron kang message, Tapos, it will undergo encryption, which can be thought of an inverse problem. So, i-code mo yung message. So, you have a message in English, and then you want to turn it into some sort of a gibberish that only the intended recipient can can understand, right? So, meron kang message, tapos magkakaroon ka ng encryption, which is the forward problem, magiging anong pwede nating itawag? Pwede natin siyang tawagin coded message, right? Or the codes, right? So ito yung inverse problem. Ito yung forward problem. The corresponding inverse problem is the intended receiver will receive the coded message, right? And it will undergo decryption. Yung decryption naman siya yung inverse problem. How we turn the codes into meaningful sentences, the gibberish into meaningful sentences. So I really like that inverse problem. And then somebody who is probably into modeling, mathematical modeling that is, submitted the problem, actually may dalawa na interesting, parameter search. Right? So halimbawa sa SEIR model, kung tama yung pagkakaalala ko. So meron nagpasa about SEIR model, and then the problem is to identify the parameters in the model, right? Kasi kung nag 175 kayo last semester, nagtingin nga ba tayo ng SIR? Parang hindi pala tayo nag-SIR model sa 175, no? Pero dun sa isang particular model, so you want to come up with, say, a mathematical equation for some useful phenomenon like, say, epidemiology. Tapos gagawa ka ng isang model. Now, ang pwede mo, the forward modeling is, alam mo na yung mga parameters, meron ka ng model, nakapag-come up ka na ng equation, gusto mo na lang mag-plug in ng, say, some variables like transmission rate, or like what, recovery rate and susceptibility rate of the population to a certain disease. Tapos ang forward, the problem is predicting how many people will be infected at the end of, say, 1 month. Right? So that's the forward problem. The inverse problem is, you know how many were infected in a particular month, and you want to recover the disease parameters, right? So alam mo na at the end of month 1, merong 1 million na nagkasakit. At the end of month 2, there are, say, 1.5 million who got the disease. At the end of month 3, there's just around 300,000 who has or who have the disease. Right, so meron kang bunch of data. So ang gusto mo ngayong hanapin, ano yung transmission rate, ano yung recovery rate, at ano yung susceptibility rate. So yun yung parang sa modeling. And somebody talk about risk assessment in banks. So maganda rin yung problem, more of a data science sort of problem. So you have several banks, and then you can classify which of them are low risk and high risk. All right. Gusto mo mag-come up ng model to determine what are the significant factors that determine whether a bank is of high risk, right? So kasi ang forward problem, alam mo yung estado ng banks, say their assets, how liquid they are. So you know some characteristics of the banks. And then you will input those characteristics of the bank into your model, all right? Tapos ang output ng model, is it low risk, high risk, or no risk at all, right? Pero maganda yung problem na pinropose. Paano ka mabubuo yung model? What are the characteristics that I need to observe from banks, knowing na etong mga banks na to sila yung low risk, mga banks na to yung no risk, yung mga bank na to yung high risk. Right? So some are very really interesting inverse problems, right? But as we go along, I hope you can either be more specific about the inverse problems that you want to solve, kasi yung iba hindi medyo klaro sa akin dun sa pagkakasulat ng nung kanilang homework, kung ano yung source, kung ano yung input, ano yung output, right? Ano yung sinosolve, ano yung phenomenon to be discussed, ano? So these are things that you need to clarify all throughout the semester. But don't worry, if you are not fixed with that particular problem, pwede pa naman natin baguhin yan towards your final project, right? So that's the homework for last time. And then, ang homework nyo naman ngayon ay magpo-prove kayo ng isang problem ay ill-post by giving me a specific condition. Paunahan ko lang advance notice. Ano? Again, the deadline is on the 19th, 11:59 p.m. So tapos, ang problem ngayon ay gagawa kayo ng noise vector. Alright? And we will learn ano yung requirement para sa noise vector na to para ma-prove ng isang problem ay ill-post. Alright? Kaya lang gusto ko ngayon ay kayo mismo yung maghanap ng noise vector and it should be unique for every one of you. Alright? So matututunan natin later ano yung mga hinahanap natin para dun sa specific noise vector para ma-prove na itong problem na to ay ill-post. Alright? Kaya lang gusto ko iba-iba kayo ng noise vector na ibigay. Ang only requirement ko lamang sa noise vector E, isa siyang 3 vectors, isa siyang vector na tatlo yung components. Ang relative size niya ay 1%. We'll also talk about it within the week. Tapos positive lahat yung laman niya. Alright? Tapos para lang ma-ensure na iba-iba kayo ng sagot or para hindi kayo makapagpasa ng may duplicate, ano? So I want you guys to do your thing, all right? Look for the vector or for such a noise vector. Tapos pag nakahanap na kayo ng nice noise vector, no? So i-check niyo bago niyo ipasa yung homework, i-check niyo muna tong Google sheet na to kung may nakapagbigay na ba ng vector na yon. All right? Kung wala pa, i-type nyo na kagad dun sa Google Sheet na yan yung vector na naisip nyo para hindi na siya magagamit ng classmates nyo. Alright? So, but we'll talk more about this. I just want to make the instruction clear para halimbawa mamaya gusto nyo na mag-start, okay na. Alright? So, yun yung ibig sabihin ko rito. So, ayoko lang na pare-parehas kayo ng E na ibigay, hindi epsilon, ng E na ibigay. So, once may naisip ka na magandang E, check mo muna si Google Doc or itong Google Sheet na to. Pag wala pa nakapagbigay ng example na yon, then i-plug in mo na. Alright? Isulat mo doon kung ano yung gagamitin mo para wala nang ibang makagamit. Alright? So, let's go to the main course for today. Alright? So, we'll be talking about operators and inverse problems. Ano? So, last week we were thinking about what inverse problems are, ano yung nature niya, at ano yung mga examples ng mga inverse problems. But, marami na kayo nabigay na examples ng inverse problems, so it's time for us now to start building up the mathematics, right? Saan tayo mag-start? Well, it turns out we should start we should start with understanding the underlying principles or the governing principles for the particular inverse problem, right? So para rin pala siyang pag-solve ng forward problem, kailangang matutunan muna natin yung governing principles dun sa phenomenon, right? Because for instance, sabi ko nga dito, in layman's terms, paano mo ma-determine kung ano dapat yung ingredients dun sa isang dish na gusto mong lutuin if you don't understand the cooking process and how the flavor of each of the ingredients will contribute to the to the actual taste of the dish, right? Or if you don't understand how the cooking process synthesizes these flavors from these different spices and different ingredients. So bago tayo magkaroon ng capability to find to find the inputs to get a specific output, we need to understand how the process works, right? So hindi lang siya ginagawa sa forward problems. So kailangan pa rin natin siyang gawin even if we are solving an inverse problem. So for instance, if we go back to the commodity problem we posed last time, sabi natin, di ba yung inverse problem natin of finding, say, what should be the price kung saan ko i-sell yung isang particular product, how many pesos, so that the demand says 100 units, right? So we mentioned the inverse problem there is to solve for x such that d of x is equal to 100, all right? But we have formulated the inverse problem here. We want to solve x such that d of x is equal to 100. But how can we solve this if we don't have a solid understanding of how d looks like, right? So hindi natin alam yung forward problem. Hindi natin alam yung kung paano nag-work yung process. So we need to have an idea how the process works, all right? At least what are the properties of the governing principle D, right? And then usually we want these governing principles or the underlying principles of phenomenon to be expressed in terms of an equation, a function or a relation that relates the inputs with the outputs. So halimbawa, dun sa demand problem, so kailangan maintindihan natin paano nag-work yung demand dun sa isang particular product. Of course, it will depend on the price X, right? Of course, there could be some other factors, pero sa model natin, price lang yung determining factor for the demand. Ano? So, kailangan ko munang malaman, ano si D of X? Ano yung proseso? So, ito yung parang pinag-aaralan nating unang step sa pagfo-forward problem. How can we compute D of 50 if we don't know what the function D looks or what the function D is? Ganun din sa inverse problem. We want to know what's the governing equation. All right? And for instance, in this particular problem, halimbawa, si D of X ay say, ano ba yung example kung binigay dito? Kalimutan ko na yung example. Halimbawa, ito yung, oops. Ito yung governing principle. So I really need to have an understanding of this governing principle. So in this particular scenario, I can define the function D, the demand function D, say, to be a function whose domain is 20 to 50. Now the domain here represents ano yung price range, ano yung feasible prices for the product. So if I define my function as or having domain 20 to 50, that means ang pinapayagan ko lang na presyo ay mula sa 20 hanggang 50. And then the codomain is the set of all positive real numbers, right? Kasi remember, si D of X ay number of products demanded. Actually, pwede nga natin itong i-limit. Pwede nating i-limit into, say, the set of integers lang kasi number of units. Pero dun sa model natin, medyo mahirap na gawin siyang integer. All right? Just to have the nice properties of continuous functions, i-allow ko muna na any positive number can serve as the number of products sold, right? So halimbawa kung merong 100.5 yung na-evaluate natin na D of X, say 100 and a half units yung demanded for the particular product, right? So kailangan mag-build up muna tayo ng equation para dun sa ating inverse, para dun sa forward problem. So for instance, in this particular case, I will let D of X to be equal to the polynomial X minus 25 times 50 minus X plus 100. All right? Now, pag alam mo na to, madali nang isolve yung problem natin kanina, right? Because this guy represents D of X. The forward problem, think of any price X between 20 and 50, plug this into D of X, then you'll get the number of products demanded, right? Ito naman sa inverse problem natin, madali na rin siya ngayong isolve kasi alam na natin paano nag-work yung demand function. So say, remember, the problem is to find how much should the product be sold to get 100 units demanded. So yung D of X, yung expression para kay D of X, i-equate ko lang siya kay 100, right? And in this particular case, what do I get? What is the answer to my inverse problem? What should be the price so that I'll get 100 products demanded? Tama ba? It should be what? Tinga kung nandiyan pa kayo. Okay guys, gising. Simpleng ano lang to, simpleng arithmetic, simpleng algebra. Yes, John Oliver.
25 or 50 po.
All right, great. Thank you, John Oliver. Yes. So if you sell the product at 25 pesos or 50 pesos, then you'll get 100 units demanded. So this is an illustration na yung mga inverse problems pala, posibleng multiple solutions, right? So in this particular case, we got two prices kung saan makukuha ko yung intended output. So that means you can choose either 25 or 50. It just depends on you, right? Or you can put some more constraints to get a unique solution, okay? Now, this D, we know this to be a function, all right? Pero ngayon, i-generalize natin yung konsepto ng isang function, all right? So that's why here I call D not just as a function, but an operator, okay? So yung operator ay isa lamang siyang generalization ng function. Kasi yung mga kilala nating mga functions, lagi lang silang ang domain ay subset ng real numbers papunta sa another real number or papunta sa isa pang set ng real numbers. Now, if we will allow a more generous interpretation of what a function is, tatawagin natin silang operators, right? But let's go there a little bit later, right? Tingnan muna natin ano yung mga pwede natin gawin with the knowledge of the governing equation here. Actually, even just knowing the properties of the governing equation will help us determine whether an inverse problem is solvable or not, unique ba yung solution, and how to go about the solution. For instance, alam ko na ito yung, ito yung governing law para sa demand function, para dun sa commodity, right? Price X will correspond to this number of units demanded, all right? So, titingnan mo to, ito ay parabola lamang na opening downward, all right? Tapos, pag kinuha ko yung range niya, ito ay 31.25 papuntang 256.25. So, a knowledge of the range can tell us ano yung mga posibleng outputs, right? So for instance, if I ask, what should be the price for the commodity so that I'll get 50 units demanded? So I know, right, with only the knowledge of the range of my operator or my function, I know that there will exist at least one solution. Kasi si 50 nandun sa range, even without doing the math. Ano? So of course, this is a very simple equation or a simple governing equation or governing function. Madali siyang i-solve. Madali siyang i-manipulate algebraically. Pero kung masyado siyang komplikado, sometimes you want to know first, will there exist a solution for my inverse problem? Or what are the possible set of outputs? Saan lang tayo restricted na solvable yung inverse problem? So in this particular case, the inverse problem of solving what the price should be so that we get a specific number of units demanded ay solvable lamang kapag yung total number of products demanded ay between 31.25 and 256.25. If I say ask what should be the price so that 300 units will be demanded, I know right away na walang nag-exist na solution sa inverse problem na yon because 300 is not within the range of the function d. Right? So ito yung mga algebraic properties ng ating governing function that can spell out the outcomes of our inverse problem. Another information that we can glean from this from a knowledge of this governing function is that look at this. The governing function is a polynomial, and polynomials are differentiable everywhere, right? So dahil differentiable siya everywhere, okay. Actually, hindi ko pala kailangan yung differentiability. This is a polynomial, so this is continuous everywhere, right? It is continuous everywhere, and the domain is a compact set, right? It's a closed and bounded interval 20 to 50. Sabi ng extreme value theorem, kung natatandaan niyo pa from your elementary calculus, EVT dictates na kapag ka meron kang continuous function sa isang closed and bounded set, laging na-attain niya yung maximum or minimum. All right? So with the knowledge of that, alam ko lamang, polynomial si D. Yung domain of definition niya ay compact set. So ibig sabihin, I can always find a price that will give me the optimal demand. Right? There exists a price such that I'll get the maximum number of products demanded. So that means even without solving the equation, we know na kung ang inverse problem ko ay paghahanap ng optimal selling price, I know that there will exist a solution. And then the things we learn from calculus will tell us how to go about the solution. Okay, sa math, usually gusto muna nating malaman, meron bang nag-exist na solution? Kasi effort yung pag-design ng solution scheme, right? Kasi hindi na dito gagana yung mga simpleng algorithms na ginagawa natin sa forward problem. So we need to make sure first that there exists a solution bago tayo mag-devise ng strategy on how to solve the inverse problem. So knowing that the function, say, is continuous and a closed and bounded set will tell us, yes, it is worth it to devise some ways to find the optimal selling price because we know that there is a maximum demand and there is a price within the domain that will give me the maximum demand for the product. All right? So, yeah. So, yun yung mga nakikita natin dito. So, a knowledge of at least the characteristics of the governing principle or the governing law, in particular yung equation o yung relation na nag-relate dun sa inputs at saka sa outputs ay napaka-crucial sa inverse problems because a knowledge of its properties can tell us meron ba nag-exist na solution or para kanino lamang may nag-exist na solution. Ano yung mga inverse problems na merong solutions for that particular problem. Alright? Now, syempre tayong mga mathematician, medyo ambisyoso tayo. Ayaw nating mag-aral ng case-to-case basis. So we always want to generalize our approach to things. So instead of tackling the governing principle per problem, gusto natin siyang i-generalize. And one way to do that is to look at different sets of governing laws and principles. So, in order to do that, nag-imbento na naman tayo ng additional mathematical object. Ang tawag nga natin sa kanila ay mga operators. But as I've alluded to earlier, operators are simply the generalization of functions. All right? So kung yung function natin na nakilala dati, isa siyang function from one set to another set. Basically, it is a rule that defines an assignment of each element of A to a unique element of B, right? So pag meron kang isang element ni A, ina-assign lang natin siya sa isang unique na element na nanggagaling kay capital B. That's what a function is. And we were used to working with numbers as the domain and the range for functions. Pero sa inverse problems, usually, hindi lamang ito yung mga governing functions or mga governing equations na ma-encounter natin. So we need to expand our definition of what a function is. So a function will not just take a set of numbers to be its domain or a Cartesian product of a set of numbers as its domain. Pwede rin siyang function ng mga functions. And kapag ka ganun na or masyadong generic yung possible domains mo para sa isang function, tinatawag na natin siya instead as an operator. And I think this is more apt to be used for inverse problems kasi nga yung konsepto natin sa inverse problems parang may process. So meron kang input, tas meron kang process, tas meron kang output, right? And this process basically is what we will define mathematically by an operator. And basically, an operator is a function from the set of all possible inputs towards the set of all possible outputs. At maraming iba't ibang klase ng mga operators. Titingnan natin sila probably in this slide. Hopefully matapos natin ngayon so that konti na lang yung gagawin natin next time. So ngayon, when I talk about operator, it's not just an intuitive or it's not just a fancy word for process, all right? So bibigyan na natin siya ng mathematical meaning. Pag sinabi nating operator, isa siyang function from one space or one set of objects to another set of objects. Makikita natin ano yung mga komplikado pang examples ng mga operators. Pero syempre, ang pinakamadaling example ng operators ay yung mga functions na nakilala na natin before. Remember from module 1, meron pa tayong isang inverse problem, the inverse problem of finding what is the number that should be added to 2 to get the output 5. All right? So again, kung gusto mong i-tackle tong inverse problem na to, kailangan maintindihan muna natin yung governing law or yung governing principle. But in this particular case, madali lang namang i-model yung governing principle or yung governing law as an operator. Kasi addition lang naman to, what should be added to 2 to get the output 5? So basically, kapag ka meron kang input x, all right, minamap lang natin to sa 2 plus x. Because again, the input is a number x, tapos ang output natin ay 2 plus the input. Yun yung forward problem, right? Yung inverse problem kasi ano yung dapat i-add ko kay 2 para makuha si 5. So in general, the forward problem can be phrased this way. Kapag ka meron akong number x, ang output ko ay 2 plus x. Kaya ang tawag ko dito sa function f na to ay forward operator. Operator siya kasi function siya from the set of real numbers to the set of real numbers. Forward siya kasi siya yung nagmo-model dun sa forward problem, right? So this is our forward operator. And what are the properties of this forward operator? So si f ay isang linear function, okay? And so it is bijective. So sinong nakakaalala nung pagiging bijective? Anyone? Anyone? Bijective? Sige nga. All right, JR said both injective and surjective. Can you build up on that, Ned? Nagtaas si Ned. Kasi yung kay JR, medyo fancy yung terms na ginamit niya. Ano nga yung pagiging injective at surjective?
Yung
Tantan mo pa?
yung function po is 1-to-1 and onto.
Right. Yung function ay 1-to-1 at saka onto. Right? So, yung forward operator pala natin, dahil isa siyang linear function, siya ay 1-to-1 at saka onto. Alright? Anong implication ng pagiging 1-to-1 and onto? Can anybody give me one implication ng 1-to-1 and onto? Specifically, yung pwede kong itali dun sa inverse problem or makakatulong sa atin para malaman kung may solution ba yung inverse problem natin or wala. So, give me a consequence ng pagiging bijective. Marami sa inyo nag-one na. So, dapat alam niyo to. Ano yung consequence ng pagiging bijective ng isang function? Actually, marami. Pero can you give me one? At least one. Kapag ang isang function ay bijective, ibig sabihin siya ay may
unique solution.
Unique solution. Unique solution kung nasulat ko na siya as an equation. Alright? Pero yung function muna. Kasi pag function, wala pa siyang unique solution kasi wala pang problem. Meron ka lang function. Ano? Sabi ni J, same number of elements sa inverse. Same number. Yeah, probably you meant same number ng elements ng domain at saka range. Ano? Kaya siya 1-to-1 and onto or domain and codomain, right? Pero what I was looking for is what Jace mentioned, yung inverse. Kapag meron kang bijective function, lagi nating alam na may inverse siya, right? So kung ang inverse problem, kung ang forward operator natin ay ito, alright? So ang f of x ay equal kay 2 plus x. We know that this is bijective. So ibig sabihin nag-exist si f inverse, right? Si f inverse, siya yung nagmamap doon sa output papunta doon sa input, right? And since we know that f, the forward operator, is bijective, it has an inverse. So there is a unique solution to this inverse problem, right? And probably this is what sino yung nagsalita kanya? I think it was Kaiser who mentioned na yes, may unique solution yung inverse problem kasi invertible yung forward operator. Kasi parang yun lang naman yung sense eh. Kung meron ka ng forward operator, kunin mo yung inverse niya if possible para makuha yung solution dun sa inverse problem, right? And even before doing the inversion process or trying to do so, alam na natin kagad na may unique solution ito. Kasi yung forward operator na to ay meron siyang inverse. So ang sagot dito sa inverse problem na to of getting what should be added to 2 to get the output 5 is simply the image of 5 under the inverse map. Okay? Now, tingnan natin yung mga operators. So, medyo kalimutan muna natin yung mga inverse problems. Kasi lagi tayong, pag nag-solve tayo ng inverse problems, lagi tayong babalik dun sa konsepto ng forward operator. Magde-design muna tayo ng forward operator, tapos itatry natin siyang hanapan ng inverse. Most likely, walang inverse yung forward operator. So, kailangan nating maghanap ng mas madaling paraan or makahanap ng paraan kung paano makahanap ng solution dun sa inverse problem or the next best thing to an exact solution, right? But that's for later. Maglaro muna tayo with the notion of operators because a grasp of operators as mathematical objects will be crucial in discussing inverse problems. So sabi nga, pwedeng mas komplikado yung domain ng ating inverse, ating operator. For instance, yung operator natin pwedeng mula sa isang two-dimensional set papunta sa isang one-dimensional set. For instance, ito pa rin yung say addition problem. Ngayon naman, missing na yung dalawang inputs. Say the inverse problem is give me two numbers whose result will be equal to 5. Alright, so kung yun yung inverse problem ko, humanap ako ng dalawang numbers ng sum ay 5, alright? It's an inverse problem because I'm looking for the inputs. I know that the target output is 5, and the goal is to solve for the inputs. So first, I will model an operator for the forward problem. Oh, it's just an addition problem. So kung ito yung input, ito yung output. So kapag meron akong dalawang numbers, I have a pair of two numbers, x and y. I'll put them as an ordered pair. Kaya ang domain ng forward operator ay r squared. Kasi ito yung, pwede nyo itong tingnan as the input space. Dito nanggagaling yung mga possible inputs, right? So that's x and y, two real numbers, and then the output is just one number, and it is x plus y. So basically, this is my forward operator because this will give me the sum of two numbers or a pair of numbers. Pero yung inverse yung isosolve ko, no? So, question, will I have a solution, or will I have a unique solution to this problem? Well, I will have solutions, right? Because this mapping is onto nga ba to? Yes, this map is onto R. Ibig sabihin, for any real number, I can find a pair of two real numbers again that will give me x plus y. Kasi halimbawa, kung meron akong target output na say, say tawagin kong z, right? Ang pwede kong kuning dalawang inputs ay si z at saka si 0, right? Because z plus 0 is equal to z. So that means, yes, this operator is onto R, or its range is R. So whatever output I get from the set of real numbers, or target output I set from the set of real numbers, I am guaranteed to get a pair of solutions from the set of real numbers. All right? Kaya lang, alam ko na hindi magiging unique yung solution na yon kasi itong function na to ay hindi injective. Alright? So, walang, hindi one-to-one itong mapping nito. Alright? So, there could be more than one pair of real numbers that will give us the same sum. So, alam ko na, itong inverse problem na to ay walang solution. Or yung solution niya ay hindi unique. Alright? Kasi multiple solutions yung pwedeng mangyari. Alright? So ito yung example na two-dimension being mapped to a one-dimensional object. And kapag ganun yung case, most likely hindi unique yung solution. Kasi nga pag mas malaki yung dimension ng input space kaysa dun sa output space, chances are hindi siya injective. Alright? Now, we can be more fancier than this. Pwede tayong mag-consider ng iba pang mga operators. In particular, kapag yung operator natin, ang domain niya na ay set of functions, usually ang ginagamit ko na ay mga curly letters. Alright? Para lang ma-distinguish yung operators. So, in particular, this example is the derivative operator. So, sa derivative operator, ang domain natin ay set of all differentiable functions. So ito na yung function ng input ay mga functions din. So ito ay function, ng laman ay function, ng output ay function. It is still a function because for any unique element of the set of differentiable functions, nakakuha tayo ng isang unique function as its derivative, right? So I hope you agree, function pa rin to. Pero ang generic term natin doon sa math, kapag function na siya ng mga functions, ang tawag na natin ay operator. So this is the derivative operator, which will take any differentiable function f to its derivative f prime. Right? Then usually, dapat, di ba, kung function yan, dapat operator d or yung function name d, tapos lalagay natin dito si f, right? So para makuha natin yung output, which is f prime. So for instance, halimbawa yung input ko ay say x squared plus 2, alright? Pag pinag-undergo ko to ng derivative operator or ginawa ko siyang input sa derivative operator, para makuha yung image, kailangan ko lang kunin yung derivative, right? Because that's the rule. If your input is f, the output is f prime, right? So ito ay magiging what? 2x lamang. So ito yung isang example na ang function natin ay, ang domain niya ay set of functions, alright? So the derivative operator, it takes a derivative it takes a differentiable function to its derivative, alright? Kaya lang, usually, minsan gusto natin na hindi lamang tingnan ano yung image niya, pero tingnan ano yung behavior ng image ng isang function under a certain operation. Halimbawa, gusto kong evaluate yung function value nung derivative ni f kay 5. Halimbawa, so gusto kong i-solve yung d of f. Remember, si d of f ay isang function. Alright? Siya ay si 2x. Tapos pag gusto ko siyang i-evaluate halimbawa kay 5, mag-aalalagay na naman ako ng set of parentheses. Tapos, Mas maglalagay ako dito ng 5. So ito ay ibig sabihin, si 5 ay isa-substitute ko dun sa mga variables na makikita ko sa function na d of f. Pero si curly d of f ay equal kay 2x, so ito ay magiging 2 times 5. So that's equal to 10. So yung d of f of 5 ay equal kay 10. But you see, ang daming parentheses ang involved. That's why whenever dealing with operators, dinadrop na natin itong parentheses na to. Alright? So we usually just write d of f, right? Para kay f prime. Kaya gusto ko lagi, kaya ibang font yung ginagamit ko dun sa operator. Kaya curly D or bold D yung ibang text, to denote the operators. Kasi dinadrop na nga natin yung grouping symbol, right? So for instance, if my f of x is x squared plus 2, then d of f is simply equal to 2x. Tapos, kapag pin-evaluate ko sa inyo yung d of f of 5, halimbawa, ang sagot dito ay 10. Because this guy, d of f or df, is basically 2x. Tapos, isa-substitute ko kay 2x, si 5, I will get 10. So, medyo baliktad ito, no? Kasi nung elementary algebra, sabi gumamit kayo ng grouping symbol as much as possible, ano? Pero dito tayo yung hindi sumusunod. Kasi dinadrop ko na yung grouping symbol para dito. But essentially, if you see d of f, it's not curly d times f. Kasi si curly d ay operator. So this means curly d is applied to f. So si f, ipapasok ko dun sa operator d. Nagkataon na si operator d ay derivative operator. So si d of f ay yung derivative ni f. At etong output na to, si d of f, ay isang function. So isa siyang function name. Pag naglagay ako ng number sa loob ng parenthesis sa tabi niya, ibig sabihin ipa-plug in ko lang to sa lahat ng variables na nandun kay d of f. So I get 10. Alright? Clear ba yung notation na to? Etong bagong notation na to? Or bago ba siya sa inyo? Alright? All clear? So para lang makita, baka mamaya magkalito-lito tayo, So si df of 5, kukomputin niyo muna si d of f, right? You let f undergo the operator d, tapos saka ka magpa-plug in ng 5, right? So that's the derivative operator, okay? Now, syempre kung may derivative operator, meron pa tayong isa pang kilalang operator, the integral operator, okay? So yung integral operator, tawagin ko naman siyang curly I. Si curly I naman ay defined sa set of all continuous functions on AB. So another function na ang domain niya ay set of functions. In particular, mga functions sa continuous sa closed interval AB. And then, this operator I will map any continuous function to a real number. Makikita nyo, ito na naman yung ang laking dimension ng input space, tapos ang liit ng dimension ng output space. Because the set of all continuous functions is basically of what? siya ay infinite yung dimension niya, pero yung output niya one dimension na lamang. So how does the integral operator work? Kapag meron kang continuous function f, minamap lang natin siya doon sa integral ni f of x from a to b. Alright? So for instance, I will give you f of x equals, say, sine x. Bibigay sana ako ng magandang function, kaya lang baka hindi ko ma-integrate. Integration nga pala to. So si sine x na lamang. Si f of x ay equal kay sine x. And note that this is a continuous function on the interval. Actually, it is continuous everywhere, right? But let's just consider the interval 0 to pi. Teka, 0 to pi. All right. Pwede naman 0 to pi, right? It's continuous over the interval 0 to pi. So our a here is 0, our b is pi, right? So I hope you agree that sine x is continuous over the closed interval 0 to pi. And then if I will subject f to the integral operator I, kukompiting ko yung curly I of f. Remember, hindi na natin nilalagay yung parentheses. If you want, you can put the parentheses. Kasi ano lang naman to, ang output niya ay real number lamang. Medyo dumarami lang naman yung parentheses kapag ang output ng operator ay function pa rin. Kasi pag nag-evaluate ka na dun sa output, you will have a bunch of parentheses succeeding each other. So dito naman pwedeng wala na yung parentheses. Pwede rin namang meron pa kasi hindi naman masyadong dadami. Kasi after you compute I of f, ay isang number na lang yung makukuha natin. Tama? That's the intended output. Kasi ang output ng operator, ang promise, real number lang. Alright? Anyone who wants to venture a guess? Ano si I of f? Ano yung image ni sine x under the operator I, the integral operator I? Sige nga. Integrate. Ano si I of f? Here. I of f is defined that way. Ano nga pala to, bonus points yung recitation. Pinag-isipan ko pa kung paano ko kukumpitin yung bonus, pero tinatali ko na siya sa Canvas so you can monitor your recitation points. Pero hindi ko pa na-decide kung paano siya if-factor in sa final grade. Announce ko sa inyo soon. Ano na si I of f? Actually, tinatamad ako mag-solve. Kaya ako pinapasolve sa inyo. Yes, JR? Or Raf, sorry. Raf nga pala.
Pwede rin po, JR. Negative cos x plus c po.
Negative cos x plus c. Try again. Bakit try again? Remember, Raf, si operator I map from C papunta kay R. So dapat yung ibibigay mo sa akin real number na lang. But nice try though. You are halfway there. Meron lang extra step na kailangan gawin. Sige, Jace. Nauna si Jace.
Di po ako sure, sir. 0 to 1 po ba?
Ano yan?
0 to 1 po ba?
0 to 1. Try again. Neo.
Negative cosine pi.
Negative cosine pi. Other guesses? Or tumama na ba? Actually, hindi ko pa siya na-mental. Yes,
Sir.
Ned? Teka, tingnan ko muna ako pala sino na. Carlo muna.
Hello,
Nakuha mo,
sir.
Carlo?
2 po ba?
2? Bakit iba-iba kayo ng sagot? Kaiser, anong sagot mo?
2 rin, sir.
2. Okay. Ned?
2 rin po, sir, kasi po parang negative 1 plus 1 po yung mangyayari.
Yeah, I think so. Yeah, I think 2 is correct. Bakit? Kasi remember, ang integral operator I, pag meron kang function f, imamap mo siya sa integral niya over the interval AB. In this particular case, I mentioned that we are considering a equals 0 and b equals pi. So ibig sabihin yung I of f ay integral ni f of x dx from 0 to pi. Tapos ito yung unang, ito yung guess ni Raf kanina, or ito yung sagot ni Raf kanina na ito ay negative cosine x, right? Kasi si f of x ay sine x, so palitan ko na siya dyan. Pero antiderivative niya ay negative cosine x, pero kailangan ko siyang evaluate from 0 to pi. Kasi ito yung operator. Hindi ka lang kumuha ng antiderivative. Yung integral operator natin actually ay definite integral operator. Alright? So, ngayon, ipa-plug in ko second fundamental theorem of calculus is negative cosine pi minus negative cosine 0. Alright? Negative cosine pi ay 1. Cosine 0 is 1, pero may negative. So, negative 1, maging positive 1 equal kay 2. Right? So, and then you check now, all right? So, bakit nagme-make sense ba na 2 yung final answer? Yes, because remember the promise of the integration process, yung ating particular operator I, pag binigyan mo siya ng continuous function, ang i-output na lamang niya ay real number. That's why I knew nung may sumagot ng negative 1 to 0 or 1 to 0, alam ko may problema dun sa sagot nila. Kasi hindi yun yung intended output ng operator. Even without doing a calculation, I know there's something wrong. Kasi nga, ang promise, pag nag-input ako ng function, ng continuous function, ang ilalabas niyang output ay real number dapat. Okay? So, I hope you get the lesson there, right? So, hold on. Take note ko lang yung mga sumagot. Carlo, Araf, Either. Okay. Is that clear? Mas okay na ba yun? So, kailangan yung sundin to the letter yung recipe na binibigay ng operator. Yung operator yung nagsasabi sa atin paano nag-work yung process. So, we need to carefully carry out all of those instructions. Alright? So, binigyan ko kayo ng function f, gawin nyo to para mo-compute yung output. Alright? And that is crucial because nga later titingnan natin yung inversion. Paano ako makakakuha ng output or paano ko makukuha yung input para ma-attain ko yung isang target output. So kailangan mo na maintindihan natin kung paano nag-work yung forward operator. Okay. Right. Probably we can look at some more operators. Ano? Sige, ano pa ba mga posibleng operators? Kasi mukhang naninibago pa kayo sa mga operators. Ano? Okay. So, halimbawa, meron akong, ito yung tinatawag natin na gradient operator. So, yung gradient operator, denoted by the symbol nabla or the inverted triangle, isa siyang mapping from the set of all differentiable function on, say, a set omega. All right? So, yung omega natin dito ay subset lamang ng R3. All right? So, si omega ay isang subset ng three-dimensional space, right? Tapos yung d of omega, siya lamang yung set ng lahat ng mga differentiable functions kay omega. Okay. Tapos, ang output nito ay, paano ko i-denote pala yung output nito? I-denote ko na lang by F3, all right? Si f ay set of functions, all right? Set of all functions. No other property required. So si f ay set of all functions. Nilagyan ko siya ng f3, so ibig sabihin ito ay set of all vectors, 3 vectors of functions. So pag nagbigay ako ng isang differentiable function of 3 variables, all right? Kasi nga si omega ay subset ni R3. So si D of omega, ito ay set of all differentiable functions on omega, which is a subset of R3. So in other words, ito ay set ng mga functions of 3 variables na differentiable. Alright? Tapos, ang output ko ay papunta sa triple of functions. Alright? This is just a vector consisting of 3 functions. Tapos, i-define ko yung image kung meron ako isang function f na manggagaling sa domain, say the operator will take it to this vector. Ito yung vector na makukuha ko. Partial of f with respect to x, comma partial of f with respect to y, comma partial of f with respect to z. Do you guys remember what is this operator? Or nabanggit ko ba kanina? Anong tawag dito sa operator na to? Kung tandaan niyo. All right, thank you, Victor. That's right. It is the gradient operator, right? So if you have a differentiable function f, you compute its gradient, it is just the 3 vector. Actually, not necessarily a 3 vector, depende kung ilan yung variables. Siya lamang yung vector na nagko-contain ng mga partial derivatives ng given function. So it is an operator because it takes a function, in particular a differentiable function of 3 variables, papunta sa set of all vectors consisting of functions. All right. So for instance, if I have f of x equals, say, sige nga, review na rin ng calculus. Sana hindi ito masyadong mahirap. Okay. Then what is the gradient of f? What is nabla f? So ano yung intended output ngayon? Ang intended output ay vector consisting of 3 functions. Isang vector na 3 functions yung laman. So kung si f ko ay x squared, y cubed plus z, ano yung gradient ni f? What is nabla f? Sige nga. So itong session na to ay parang ano lang, parang ini-introduce ko lang kayo dun sa notations o symbols na gagamitin natin later. Yes, Denmark?
Hello po.
Hi.
2x,
Mhm.
3y squared,
Kama
one
na ba
po.
'yon?
Comma,
Comma.
2x, 3y squared, 1.
Okay. Any other answer? Parang may kulang, Denmark. Do you want to amend your answer? Yes, Carlo.
Hello. Ano po? 2x y cube plus c, comma, x squared 3y squared plus z, comma, x squared y cube plus 1.
X squared y cubed plus 1. I think kailangan ding i-edit tong sagot na to. So, talaga nag-adjust pa kayo, no? Kasi hindi tayo magkasundo-sundo sa simpleng calculus. Thank you. Who's that, Carlo? Yeah. Sige, yung hindi pa nakasagot. Crizel? Meron kang entry?
2xy squared po, sir. Comma,
2x.
2xy squared po.
Aha.
2x squared y po.
2x squared y.
1 po.
Comma 1. Tama na ba to? 2. May kailangan ding i-edit. Next, sino susunod na? Neil Christian. Ba't hindi tayo magkasundo-sundo sa simpleng calculus?
2xy cubed, 3x squared, 3x squared, y squared, 1.
Okay, finally, I think that is the right answer. 2xy cubed. Kasi ipa-partial natin, yung unang entry ay partial nito with respect to x, right? So partial niya with respect to x. So si y at saka si z ay treated to be constants, right? Treated as constants. So ito ay constant. Kakopyahin ko siya. Derivative nito, 2x. Alright? The next, partial nito with respect to y. So all other variables are treated as constants. So ibig sabihin si x at saka si z ay mga constants. So si x squared ay bababa kasi treated as a constant. Derivative ni y cube ay 3y squared. Derivative ni z ay 0 kasi nga treated as a constant. And then partial of f with respect to z. This is treated as a constant, derivative 0, derivative ni z ay 1, so I guess this is the answer. Okay, thank you. Pero maganda yan, at least meron tayong participation ngayon, so nare-review tayo. Kasi later gagamitin natin yung mga topics na yan. So we learned today that we need to brush up on our calculus, para magkasundo-sundo tayo, first attempt, magkasundo-sundo tayo, then sa final answer. All right? So that's the derivative operator, that's the gradient operator. Now, another operator na probably na-meet nyo na rin ay ito. This is the nabla dot operator. Pero meron siyang mathematical name, sabihin ko siya later. Ito ay isang operator mula sa set of all differentiable functions, say of 3 variables. So si omega natin subset uli ng R3. So si d of omega, set of all differentiable functions of 3 variables, right? Over the set omega. Tapos siya ay f na lang. Right? So ibig sabihin, isang function na lamang yung output nito. Basically a function then of 3 variables. So siguro sulat natin f of omega. Function of 3 variables din. Tapos ganito nag-work yung math. Pag binigyan ako ng isang function f, differentiable function f of 3 variables, ang image niya under nabla dot ay partial of x, partial of f with respect to x plus partial of f with respect to y plus partial of f with respect to z. What do we call this map? Tandaan niyo ba from calculus? So kanina, binuo natin yung gradient to be the vector containing all 3 partial derivatives, right? So yun yung nabla operator. Yung nabla dot operator naman, ganito yung ginagawa. Instead na kunin yung vector consisting of the partial derivatives, we are taking the sum of the partial derivatives. And that's why here, our output is not a vector of functions, but simply a function still of 3 variables. Kasi nga, kukunin ko yung partials, tapos ipag-add ko lamang sila. So what do we call this? Tandaan niyo ba? Pinalimutan niyo na rin?
Hello po, sir.
Hello, sino to?
Dahil po. Hindi po ako makapag-grade sa theory. Total partial po. Total partial differentiation.
Total partial derivative. Actually, inisip ko kung tama ba yung definition. Sa total partial, parang may multiplier pa ba yun? Yeah, honestly, I forgot the definition of total partial, kung paano siya tinitreat, Pero iba yung hinahanap kong name dito. May mas common na name para dito. I'm not sure if total partial is also acceptable. Pero I think may kulang na expressions. Pero may isang mas popular name for this. Starts with a G. Sorry, not a G. A D. Bigla naglagay birth letters, no? Mahaba kasi siya, so hindi ko na itutuloy. So yung tawag dito, this is the See it na? This is the divergence operator. All right? Saying nabla dot, siya yung divergence ng isang function. All right? So kung meron kang function, so kukunin mo lang yung sum ng mga first partial derivatives niya. So for instance, if our function f of 3 variables, I say si sine xy plus e to the z, ano? So yung nabla dot niya, okay, which is basically the gradient. So minsan, kaya siguro hindi familiar, hindi nyo ginagamit yung nabla dot, alright? So baka yung ginagamit nyo ay grad operator. So yung gradient operator, hindi gradient. Gradient na nga pala yung kanina. This is divergence, so div minsan yung ginagamit. So div f, this is the divergence of f. So kukunin lang natin yung sum ng mga partial derivatives niya. So ang nabla dot f o yung divergence ni f ay sum lang ng partial derivatives. In this case, that will be 1. So that would be cosine of xy tapos my y, right?
Plus x cosine y plus z
Hindi ba
raised
xy?
to z. Oo, cosine.
Tama ba?
May kulang na z. Kulang ng z sa la. Ha? Hindi ba kulang ng z?
Tama ba to? Yeah. Kasi sine of something, derivative niya ay cosine of something. Tapos nagpa-partial ako with respect to x. So si y ay treated as a constant. So derivative chain rule, derivative ng xy with respect to x ay y lamang. So kaya nagka-y sa kabila. Tapos yung second term partial with respect to y, exactly the same thing. But this time, x is treated to be the constant. So x comes out kasi derivative ng xy with respect to y ay x plus derivative ng e to the z. All right? So thank you, Neil. And I think Kaiser agreed with me. So I think tama na to. Yan yung divergence ni f, right? Now, what is del f? What is del dot? Kulang pala to. Nabuko tuloy yung gusto kong gawin. Sige nga, ano tong number na to? Nabla dot f of 011. Ay, it's okay lang, Neil. At least, thinking aloud, yes, Kaiser?
Wait. Di ako sure sa pero E?
E?
lang.
Sige, other entries. Parang iba yung sagot ko sa'yo. Teka, nag-ano lang ako. Nag-mental. Parang kulang. Anio?
1 plus E, sir.
1 plus E. Other entries. Taas ng kamay. Sino pa yan? Jane? Sige. Anong sagot mo, Jane?
Hello po. Same lang din po, 1 plus E.
Right. I think, Kaiser, you missed the 1. Bakit nagka-1? Galing dun sa first term, no? Kasi dito, ito ay naging 0. Ito ay naging 1. Ito ay naging 1. So 1 times cosine of 0, which is 1, plus E to the 1. Alright? Kasi again, kukomputin mo muna yung image under the operator, tapos saka mo ipa-plug in yung 0, 1, 1. Hindi siya nag-work this way, ano? Ito yung gusto kong i-drive at this particular point, ano? Pag meron kang operator followed by a function, i-perform mo muna, followed by a function evaluation, perform mo muna yung operator bago ka mag-plug in. It doesn't work the other way around. Hindi ka muna mag-plug in kay f ng 0, 1, 1, saka mo siya ipapasok dun sa operator. What you should do first is get the image of the given function under the operator, and if the answer is a function, then that's the only time you plug in the given thing. Ano? May isa pa. Ano nga ba yung isa pa? Kasi nagubos lang ako actually ng oras. Magandang review ng mga operators natin. Ito pa, isa pang operator ay yung, hindi ko alam kung na-meet nyo na to. The Laplacian Operator. Yung Laplacian Operator ay set of twice differentiable functions, say, of 3 variables, alright? Tapos papunta siya sa f of omega. So, ibig sabihin, kukuha ako ng isang function that is twice differentiable. Tapos, ang output niya ay isang function of 3 variables pa rin. Right? And the operator delta, or this is what we call the Laplacian operator. I think you saw this in the temperature problem that I posed in module number 1. Yung Laplacian operator nag-work this way. Pag meron akong function f of 3 variables that is twice differentiable, its Laplacian is the sum of the following second partial derivatives. Kunin mo yung second partial with respect to x, second partial with respect to y, second partial with respect to z, tapos kunin natin yung sum nilang tatlo. Alright? So yun yung Laplacian of the function of a given function f. So for instance, isang madaling example lang kasi magta-time na pala. Halimbawa, sige nga, madaling function. Ano ba madaling function? E to the x, sige. E to the xyz na lang. Sana madali lang to. Ay, kaya lang ayan, madali lang to. Tapos, kukunin natin halimbawa yung Laplacian of f of, say, 0, 1, pi. Okay? So, pag isolve ko yung Laplacian of f at 0, 1, pi, okay, I need to solve for the Laplacian first. Right? Solve ko muna si Laplacian, tapos saka ko siya evaluate sa 0, 1, pi. Right? So, kunin natin yung Laplacian. Yung Laplacian ay second partial derivatives. Tapos kukunin natin yung sum, tapos para makuha tong number na to, ipa-plug in ko si 0, 1, pi. Pag nakuha ko na yung Laplacian. Ano? Pero ano si Laplacian? Okay. Partial derivative. Second partial derivative. With respect to x, ang derivative ni e to the xyz ay sarili niya times, ano yung multiplier dito? Partial with respect to x muna. Partial with respect to x, siya ay magkakaroon ng, tama ba? Yz, no? Kasi it's x times a constant, derivative niya ay yung constant, so yz. Tapos kukunin ko ulit yung partial nito with respect to x. Ang partial niya with respect to x ay, tama ba? Sarili niya. Yz, e to the xyz, bababa si yz. So ito ay yz squared e to the xyz. Tama ba, guys? Ito yung second partial with respect to x. Kailangan ko rin palang reviewin para mabilis ako mag-differentiate. Tama nga ba? Ito yung partial with respect to x. Para magkuha yung second partial, kailangan ko ulit itong partial derivative with respect to x. This is treated as a constant. So, kinopya ko lang siya ulit. Tapos, dinifferentiate ko to. Ang derivative nito ay e to the xyz. Nag-chain rule ako, nagkaroon uli ng panibagong yz. Alright? So, nakita ko na may nag-thumbs up na. Thank you. So, ibig sabihin, ganun lang yung pattern. Yung partial ni f with respect to y ay e to the xyz times what? Ano yung multiplier naman ngayon? Discerning the pattern. Ito ay xz squared. Tama ba? Tapos, yung third ay xy squared e to the xyz. Right? Tapos, dahil in-evaluate natin sa 0, 1, pi, plug-in ko lang dito, x equals 0. So, this vanishes kasi meron siyang multiplier na x. So, magzi-0 yan. Tapos, ito rin magzi-0. So ito lang yung matitira na mayroong possibly non-zero terms. Exponent nito ay magiging 0. So e to the 1, this will just be 1. So this will just be yz squared evaluated at y equals 1 and z equals pi. So this would be pi squared. Tama ba? Alright, so yun. Lesson ngayon, kailangan natin mag-brush up pare-parehas sa calculus natin. Ano? So, but I hope this serves as a good introduction to operators. But again, we have spent the first probably 30 or 45 minutes talking about why forward modeling or finding the forward operator is important for inverse problems. Tapos nag-familiarize lang tayo with operators for today. Now, we'll deal more with operators as we go along the course, pero on Thursday, we'll look at the properties, the desirable properties for a mathematical problem. I will tell you that we will follow Hadamard's convention of a nice problem. Sabi ni Hadamard, ang magagandang problem sa math ay yung may at least one solution, at most one solution, at yung solution ay nagde-depend continuously dun sa data. So those three requirements are what we call Hadamard's requirement for well-posedness. So if a problem satisfies all those three properties, then siya ay isang well-posed problem. Pag may isang nag-fail, ang tawag sa kanya ay ill-posed problem. So on Thursday, we'll talk about ill-posed problems, or actually well-posed and ill-posed problems in preparation dun sa homework na kailangan yung gawin. Pero just a quick announcement, on Thursday, mag-start tayo a little late. Let's start at 10:30. Then we'll finish at 11:25 siguro, right? Kasi I have an important meeting ng 9:30 with OVPAA. So hindi ako makahindi dun sa pa-meeting nila. So I need to be there. So apologies. Pero mag-meet pa rin tayo. 1 hour lang naman daw yung meeting, 9:30 to 10:30. So I can still meet you 10:30 to 11:30. All right? So any questions? Okay. Oh, before you leave, those who recited verbally, pwedeng pa-comment ng nickname or ng name and nickname. Ano? Though yung iba na take note ko na, I might have forgotten some people. I think Jane also recited. Chriselle also recited. Tama ba? Then kung nakalimutan ko kayong isulat, pakisulat yung pangalan nyo or yung nickname nyo dun sa chat box before you leave. Kaiser recited. All right. Raf recited. Hindi ko yata nilagay. Oh, si Neil nag-recite, yeah. So, but after you do so, yeah, you can now leave now. Takbo na kayo sa susunod yung face-to-face class. So, thank you guys for coming today, and let's see each other again 10:30 on Thursday. Bye, everyone.
Thank you, sir.
Yes, sir.
Thank you po, sir.
Thank you, sir.